Hey, welcome to Weld.com, home of Tig Time. Hi, I'm Mr. Tig, and I've got Kevin Carone here with me from kevincarone.com, artist, sculptor. And we've had a lot of questions on both of our websites, and I've had this question over and over and over and over again, and I would have to assume that you do too.
I get it a lot. Yep.
What is the difference between Tig and Mig, and why would you use it?
And why do I need it? Absolutely, yeah. I get it a lot. So we've been playing a lot with the different Tig machines that are here. We've done a lot of Tig welding, and from the way I see it, now Tig it's so precise, it's so clean, that most of the time there's no cleanup to do when you're done. You get a nice perfect bead down there, your parts are together, you've got a good looking bead, you don't have to grind it, you don't have to smooth it, you don't have to do anything with it, from his point of view. From my point of view, when I'm working on a sculpture, yeah, I'll do all my structural welds with my Tig, they're good, they're solid, I'm just ecstatic with the way they look. But if I've got a long run to do, I've got a tall sculpture I'm building, I've got 10, 15 feet worth of weld that I want to get done. I don't want to sit there at half an inch a minute with a Tig. I'm going to get the Mig out, and I'm just going to go ahead and set it up, and I'm going to get all my runs done. I'm going to do my darndest to make them look like a Tig when I'm done with it, and then I can come back with my grinder and just touch them up just a little bit, and they're done. They go on to vanish, but I still get my work done. So, you've got short run, high technical, beautiful welds, that's a Tig. But when I'm going to do these long production welds, I'm going to reach for the Mig.
Okay, well, from my perspective, I've been in Tig my entire life, and I like the precision. I like the ability to be able to do aluminums and stainless and Inconels, all of those with the one machine, the same gas. And I know it's not high production,
right,
but it is precision. So
yes.
when I try using that other welding process, it sounds so easy to be able to pull the trigger and weld.
And it is.
And when you're welding steel, I can understand that. But have you ever tried using that welding process to do aluminum?
You can say it. It's okay.
It's aluminum MIG welding. And I find it very difficult. I don't know if you've had any experience with it.
Not at all. It's not difficult at all. I actually think welding with a spool gun on a MIG machine is actually as easy, if not easier, than welding with steel.
Okay. And you just identified it, a spool gun.
A spool gun.
Now what I have on my website, I get a lot of questions on this process, this MIG process. And a guy goes out and he buys a MIG machine from a hardware store, big box store, goes home, sets it up, and he welds steel beautifully.
Right.
And then all of a sudden he puts a roll of aluminum on there and thinks it's going to weld nice.
Not going to work.
It just doesn't happen. Now what happens is these spools are very small spools. You're using typically 40-43, which is the right filler material. It's just that you can't push that wire.
You can't push it through the machine.
It binds up.
Right. Now they have something called a push-pull gun, where not only do you have the rollers in the machine that help drive it out of the machine, but you also have another set of rollers in the gun itself to help pull the wire.
Okay.
And then you can do about a 15-foot run with aluminum and still be able to work that way without having a spool gun in your hand. But the push-pull gun is almost the same size as a spool gun. It's a big clunky machine, and it's very, very expensive.
Okay, so, well, can you give me a quick rundown? We were doing Tig here recently, and we did some aluminum and some stainless. Can you go through the components of a Tig Torch, if you will? I mean, the back cap and all that.
Yeah.
And then go through the MIG process and just compare the two.
We have a pedal, because this one does not have a trigger on it. So the pedal, just like the gas pedal in a car. It's sitting this way, the car doesn't go anywhere. The harder down you push on the pedal, the more electricity goes to the torch, the hotter the arc is, the faster you weld. Okay. Just like in a car. So let's get him out of the way for the moment. And we get into the torch itself. All kinds of little parts and pieces. And sharp. Thank you, Wyatt.
My pleasure.
What a guy. So there are all your parts. You have your torch body. You have, in this one, this is a gas lens. And if you come a little closer, let me show you this. inside here, you'll see this little mesh. And it's kind of like a window screen, only much, much finer. And there's several different layers inside of there. So what it winds up doing is, as the gas comes through, instead of having like a garden hose with the gas just falling through it, it tumbles and falls and you wind up with turbulence down at your weld. This is like the wind when it comes through the screen on your door. You know, it helps to funnel, it helps to shape it, it helps make it go straight and smooth, so you get more of a column that comes out. Greatly increases the amount of coverage, you know, and how well it works on a piece of metal when you're welding. Great addition to any Tig torch, a little gas lens. These little, come here, big fingers. And little tiny tungstens. Several different sizes, right?
Yeah.
What is the range and size of a tungsten?
You know, actually, they come in, I carry 20 thousandths diameter up to, you know, 5/16. I can even get 1/4 inch diameter if you're doing heavy duty welding.
Whoa.
But this is what I use for micro welding.
Okay.
It's, you know, you can use 40 thousandths, put a fine point on it, and you can light an arc at, you know, 2 or 3 amps.
And this is probably just right about the same size, if not just a little smaller than a safety pin.
It is,
in diameter. And just as sharp as one, actually. And yeah, the collet body itself, with the tungsten gas lens with the collet body in there, this is the collet itself that would fit down inside. You would put your back cap on, and then your tungsten would just go up inside. Snug that down just a little, and your cup would go on. Leave that out just a little farther. Your cup would go on. This helps shape the flow of the argon as it comes out, so it's, you know, getting down on the metal correctly. Comes in different diameters. You know, why would you have a different diameter? But why would you go from this size to one smaller or one higher, or one bigger?
Sometimes the orifice opening is critical, especially when you get into the finer amps. If you go to lower amps, the diameter can be much smaller.
Okay.
And you'll turn your gas down accordingly.
Okay, cool.
And it'll be a softer start.
Cool. And going to a smaller diameter lets you get, you know, farther down into a corner somewhere. You know, you're working down in a little tight space.
It does.
You know, the bigger one, larger coverage. Cool. You know, these are, you know, they're such fun little pieces, and they're so mix and matchable. You know, you can do so many different things. You can actually go to a smaller end cap than this that's only, you know, this long, or you can put the full size, you know, the full length on there where you can get the whole 7-inch long tungsten inside there and just go from there. So that's what's inside a Tig torch, you know, when you finally get down to it.
Okay, you have another torch up there, and it looks a little bit different.
It's a little different from a Tig, yeah. So this is a MIG gun, if you will, or a MIG torch. It has just a trigger, and it has a nozzle, and it has a tip, or electrode, if you will, that goes in the end, but normally they're called tips. Different sizes, you know, different size holes for the different size wires that you would normally run. And then, and then this is the little brass connector in the end of it. It helps hold the liner in the gun, or in the cable that the wire actually feeds through, you know, that little nylon or Teflon liner inside there, to make it easier on the feed roller so it can push it through. And you can see the holes in here is where the gas comes out from your bottle. That's where the inert gas comes out to go through your nozzle to be able to shield your work. Very easy.
Okay, now we're talking about shielding. What kind of shielding do you use on this?
Normally, you would use a 75% argon and 25% CO2.
Okay.
You know, commonly called a MIG mix or a MIG gas. On occasion, you will use a tri-mix where you will have, you know, argon and carbon dioxide, and you'll put a little helium in it for, like, if you're doing stainless.
Oh, okay.
You know, just to boost the heat a little bit, so you can work with the harder metals. And that's it. That's all you need. With the Tig, now of course you have filler rod, And the TIG becomes basically a three-handed process, or 2 hands and a foot, because not only do you have to hold the torch, but you need the filler rod, you need to be able to fill it, and then of course that's where the foot pedal comes in. You need to be able to run the electricity from down there, to be able to make it hotter or colder, so you can feed it all in. So when you get to the point where, okay, I want to hold a piece of metal right here, and I want to tack it, now you're reaching down there with your nose or something to try to hold that thing in place, or you're trying to hold it and hold the metal at the same time and be able to tack it. Now, I'm sure you're much better at this than I am, as far as tacking with a TIG. I normally wind up vaporizing something, Yeah. So what I do is I like to have both machines set up, where when I'm doing my initial setup, I want to tack things in place, I'll reach for the MIG, because it is one-handed. You only need the one hand to hold your gun, and then you can get your piece of metal, you can put it in place, you can pull the trigger, zap it, get everything tacked together, and then put it away. I'll get the TIG out, and then I'll come back and do all my finish work with the TIG. Nice, beautiful, clean welds, nothing to clean up at the end of it. Because you get a little splatter, you get the little dingle balls that come off, so there's a little bit of cleanup left over. Not anywhere near as bad as using a stick welder. There's no slag to clean out, clean up, there's none of that. But I still wind up coming back with the grinder, coming back with the scraper or something, just to get a nice smooth surface when I'm all done.
Okay, so we're set up right now. It looks like you got some steel wire in there.
I got some solid core wire. We got some gas ready for it. So we can just put our gear on, and we can run from, we've got some 16 gauge, we've got some 1/2-inch plate over here, and we can just play a little bit, and I can show you the wide range of work that this little Lincoln will do.
Okay, let's put our gear on and see what it'll do.
Spark it up. So just to show you real quick, we're playing with a Lincoln SP135 Plus. It's a little 110 volt welder. It's the biggest transformer machine that runs on 110. The largest power output out of it. I just wanted to show you inside real quick. Spool of wire. This is where it goes on. These are your feed rollers right here. You loosen this little wing nut up. The lever drops down. You pick up the roller. You feed it through, and it just comes out the gun. You have a positive and negative connection that you would switch from one to the other. If you're running solid core, you want it this way. If you're going to run flux core, so no gas, you would switch it the other way. Now, you would also change these connections when you have a spool gun. You want to pull one off to hook your spool gun up to it. Great little chart on it showing you the various connections, the various settings, whatever you need, what kind of metals what thicknesses of metals you're working with, the gas, the wire, the processes. Great handy little chart that they put inside the machine so you know what you're doing. You can at least get a guideline, get some place to start from. On the front of the machine, very simple, very easy. Just an on-off switch. You have your arc volts and from A to J. So you'll get a hint. You'll learn where those are as far as what voltage you're actually getting. You can also pick that information up off the chart itself. And then you have wire speed from nothing to a whole bunch. And you'll learn where to set all that from the chart. So you know what thickness you're using, what kind of voltage you're running. You'll get a good guideline as to where to dial it in, where to start from, and then you can dial it in as you're working. So let's fire it up. Let's make sparks. And you see, with just a little pull of the trigger, and it's that easy. Pull of the trigger and go. There you are. Now, there's a few little tricks you can learn. One of them is being able to spot the little bubble. There's a little bubble. There's a little dot. And we can go in that in another video if you want. But easy on the 16 gauge. You know, let's bump up the voltage a little. We'll bump up the wire a little bit. So 16 gauge, no problem. Turn up the voltage all the way. Turn up the wire speed a little bit. So let's try some 1/2 inch. See what I mean? No, it's that easy. And just like TIG, when you want to build a race car, you want to build a motorcycle, you want to do any of that, MIG work gets into a lot of different areas just for the production runs. Okay. Now, I would probably have gone with about a 200 amp machine or a 250 amp machine for welding something this thick, cold, but I have come back in and preheated something like this with the oxygen acetylene torch.
Okay.
And then be able to come back with the lower power machines once you get the metal warm enough and come back in and weld it again. Be able to do it.
It was actually pretty impressive because so many times a person buys a machine doesn't know how heavy duty it is.
Right.
And I can see the 16 gauge ran beautiful. You could hear it. It wetted out nicely.
It was perfect.
And we took it to an extreme. We took 1/2 inch.
Right.
Is this machine recommended for 1/2 inch?
No.
And the answer is no. It isn't.
No. I would say maybe 3/8 at the most.
But I mean, you perform miracles with it to get it to stick and to make it look that decent.
Right.
But so many times you buy the machine for the wrong reasons. But I like any time that I use this process, which is not very often. I rarely exceed 1/8 of an inch.
We'll work on that. We'll change it. I think the biggest lesson here is if you can afford a little more power, go get it. If this is what you're using, if this is all you can afford, and you're just playing in your garage, you're building stuff for the house, great little machine. It'll handle a good 75% of anything that you're going to run across. But I think you'd wind up outgrowing the machine pretty quick. Once you get used to playing with the thin stuff, you're used to making, yard art, things to hang on the walls, pop rack, stuff like that, and you're going to want to move up. But it's still a fun machine to have handy because even the one that I have found uses for it where I've got to go outside, I've got to go on location somewhere. They don't have 220. So I can take my little 110, I can change the wire size, I can go down in wire size a little bit so I can basically up the amps, I can make it hotter, and be able to still work out in the field with it. So, fun machine.
That's great. Well, Kevin, it's been great having you on our series of shows.
It's been fun. Thank you.
And thank you for taking over this portion of it. I needed the help.
There you go.
So thank you very much.
Thank you, sir.
And thanks for watching Tig Time. I'm Mr. Tig.
I'm Kevin Carone.
Have a good evening.
See you later. While Wyatt is shaking the dew off the lily, I'm going to go ahead and play with the torch here a little bit.
See how it starts?
Yeah, where I get roasted repeatedly. Jingle bells, jingle bells. That's what I sound like.
I'm sorry. I have to get back out my big shot. Okay. Ready?